All right, guys, we're going to do section 4 of chapter 11 now, which deals with multiplying and dividing rational expressions. So previously, you multiplied polynomials and divided monomials, and now we're going to actually multiply rational expressions and divide rational expressions. So those are some of the vocabulary we're going to come into: multiplying rational expressions, dividing rational expressions, and something called dimensional analysis, which sounds pretty cool, and it's not too scary, so we'll check it out. So first, let's talk about multiplying rational expressions. To multiply fractions, you multiply numerators and multiply denominators. Just like with numbers, you multiply straight across the top, straight across the bottom. So we use that same method to multiply rational expressions. So remember, a rational expression contains a monomial or a polynomial in the numerator and in the denominator. So when you're multiplying rational expressions, you multiply the numerators and multiply the denominators. Now the thing is, sometimes you're going to have factors that cancel out. So whenever you multiply rational expressions, you always want to simplify and write it in lowest terms. So let's find the products here. R squared x over 9t cubed times 3t to the fourth over r. Now we would just multiply this straight across the top, straight across the bottom, but we can divide out the common factors before multiplying to make the problem simpler. So do you remember if, for example, when you had 4/9 times 27/16 or something like that? Well, you could multiply those straight across, and 4 times 27 and 9 times 16. Yeah, and then you'd have to reduce that. Or you could cross cancel the 4 and the 16, and that would make this 1 and that 4. And the 9 and 27, you could reduce that and get a 3 over 1. And then you just multiply 1 times 3 is 3, 1 times 4 is 4. So reducing first, or cross canceling first, canceling out those common factors, simplifies the problem before you multiply. Now, you could do it after you multiply, but then you'd have to go back and simplify again. And sometimes it's more difficult to simplify after you multiply. So anyway, here you have a common factor of r in the numerator of this fraction and the denominator of this fraction. So you can cancel out a factor of r. You have 3 common factors of t, so you could divide out a t cubed from both of these, and a factor of 3 from the 3 and the 9. So once you cancel all those out, you're left with r, x, 1, and t in the numerator, 3, 1, and 1 in the denominator. And when you multiply those together, you get rxt over 3. Let's check out this one. A plus 4 over a squared times a over a squared plus 2a minus 8. Now this one we have not just multiplying monomials, but we have a binomial and a trinomial. And what we can do is, before we try to multiply, we want to simplify. Well, it doesn't look like there's any common factors except with the a and the a squared. But this a squared plus 2a minus 8, let's factor that first, okay, into a plus 4 times a minus 2. Remember, when you're factoring a trinomial and the leading coefficient is 1, you want numbers that multiply to the last number and add to the middle number. Okay, so factors that multiply to -8 and add to 2. Well, if they multiply to a negative, one has to be positive, one has to be negative. And if they add to a positive, the bigger of those two have to be the positive. So +4 and -2 are the factors that work. Now you can see you have a common factor of a plus 4 in the numerator and denominator that can cross cancel, and a common factor of a that can cross cancel. So let's cancel those out. And once you do that, the numerator, notice everything canceled out, but it doesn't mean the numerator goes away. That's one of the most common mistakes I see, is that the numerator goes away, okay? So you cross cancel out the a plus 4 and the a's, and there's still a 1 remaining in the numerator. And then the denominator is a times a minus 2. You could leave it in the factored form or distribute the a to make it a squared minus 2a in the denominator. Okie dokie. All right, here's a couple for you to try. Go ahead and pause the video. All right, we're back. Let me rewrite the first one first, like that. Now you can cross cancel. Let me do it in red so we can see it. Cross cancel a 3 and a 3, you get 1. An 8 and the 16, you would get 2. These x squareds just straight up cancel out. So you're left with 1 times x times 1 times 1, which is just x, over 2 times 1 times 2, which is just x over 2. Okay. Now in the next one, 1b, you have x plus 3 over x times 5 over, now I need numbers that multiply to 12 and add to 7. 3 and 4, right? 3 times 4 is 12, 3 plus 4 is 7. So x plus 3, x plus 4. You can see that the common factor of x plus 3 cancels out. Here and here, and those would cancel to 1s. And there are no other common factors, so the numerators multiply to 5, and the denominators multiply to x times x plus 4, which you could write as 5 over x squared plus 4x, if you wanted to. I'll box my answer there. Kiddo? All right, and then 1c, let's factor the numerator here. Numbers that multiply to -4 and add to -3. So it would have to be y minus 4 and y plus 1 over y plus 5. The numerator here, you got y plus 5. Now the denominator, y squared minus 4y, has a GCF of y. So we have y times y minus 4. And then you could cross cancel the y minus 4s, and those would give you 1s. And then the y plus 5s, and those would give you 1s. And then that would all cancel out to y plus 1 over y. All right? Pretty cool, huh? Okay, so when you multiply fractions that involve units of measure, you can divide by the units in the same way you divide by variables. Recall that this process is what we call dimensional analysis. You can use dimensional analysis to convert units of measure within a system and between systems, as long as you know the conversions. So Ann Proctor won the 2007 World Water Ski Racing Championship race in her category when she finished the 88-kilometer course in 51.23 minutes. What is her average speed in miles per hour? So we know her distance in kilometers is 88 kilometers, and her time was 51.23 minutes. So if we want to get to miles per hour, it's given to us pretty much in kilometers per minute. It's 88 kilometers per 51.23 minutes. That's the rate at which she's going, and we want to convert that to miles per hour. Well, they give you a conversion to get it to be from kilometers to miles. They give you the conversion there. And you should know that minutes and hours, there's 60 minutes in an hour. Some of the conversions they might give you in the problem if they're not really commonly used. But if they're common ones that we use every day, they kind of expect you to know those ones. And if you don't, you can just Google it and just go, how many miles are in an hour? I mean, how many feet are in a mile or something like that. Okay. So what we want to do is you have 88 kilometers for 51.23 minutes. We want to cancel out the kilometers first. Now, you could have canceled out the minutes and converted it to hours first. Doesn't matter which one you do. We're just doing kilometers first. So if I want to get rid of the kilometers, I know I need to multiply by 1 or 0.62 over 1 instead of 1 over 0.62, because when you put the kilometers in the denominator, they're going to cross cancel the units, okay? And then that's going to leave miles. Now, the next thing I need to do is convert the minutes into hours. How do I do that? Well, I know there's 60 minutes in an hour. So do I multiply by 60 over 1 or 1 over 60? Well, if you're trying to cross cancel out the minutes, you put the minutes on top and there's 60 minutes in an hour. So those would cross cancel here. And notice the units that are left are miles over hours, miles per hour. So then you just multiply straight across the numerator and denominator. And you get 63.9 miles per hour, okay? So her average speed was about 63.9 miles per hour. Okay, here's one for you to try. What's Ann's Proctor's speed in feet per second? Okay, so she started out at 88 kilometers in 51.23 minutes. I'll write that down so that it's there for you because you know her speed in kilometers per minute now. All right, go ahead and pause the video and hit play when you're ready. All right, we're back. So we know that she went 88 kilometers in 51.23 minutes, and we want to go to feet per second. Well, I know there's 60 seconds in a minute, so if I want to convert minutes into seconds, I want the minutes to be up here and the seconds to be down here. So there's 60 seconds in 1 minute, and that would cross cancel the minutes and give me seconds. Now the next thing I need to do is convert kilometers into feet. Now I don't know the conversion from kilometers straight to feet, but they did give me in the problem the conversion of kilometers into miles. So if I want to cancel out kilometers, and the reason I go to miles is because then I know how to go from miles to feet. So anyway, I want to cancel out kilometers, so they go in the denominator here and miles up here. And they said 1 kilometer is 0.62 miles. And then I have to do a third fraction that cancels out miles and converts it to feet. So feet would be up here and miles would be down here. So you should know there's 5,280 feet in 1 mile. Okay, if you don't remember that, again, you could just Google that and see how many feet are in a mile. All right, so the minutes cancel, then I got my kilometers to cancel, and I got my miles to cancel. Now, if you look, the only units that remain are seconds and feet, and since the numerator is feet, it'd be feet per second. So your problem would be 88 times 1 times 0.62 times 5,280 feet over 51.23 times 60 times 1 times 1 seconds. And if you multiply that all out, so you can multiply the whole numerator, get that answer, multiply the whole denominator, get that answer, and then divide, and you would get 93.72 feet per second. Okay? All righty. Well, that's it for this first video. Please stay tuned for the next one when we'll talk about dividing rational expressions. See you there.